This video focuses on what a power can do to a negative number. We're going to start by looking at some even powers. The first example on the right is what we're going to start with. -2, that whole quantity, is being squared. When it comes to exponents, the number goes to exactly what it is beside. So in this case, the 2 is directly beside the set of parentheses, which means that the 2 goes to the entire parentheses. So that means that this whole thing, this whole -2, is the base. And of course, the 2 is the power or the exponent. The power of the exponent tells us how many times to write the base. And then we multiply. We have a multiplication sign in between the number of times that we write that number. So -2 multiplied by -2, we get 4. And this is where a lot of kids get confused. A lot of kids think that -2 squared over here is going to give you the same result, but it does not. Like I said before, the power goes to what it is directly beside, and that 2 is only directly beside the 2. So the 2 is the base. You'll notice that the negative sign is not included in the base. So the negative sign can be written out here, and then the base of 2 is what is copied 2 times. So this actually results in a -4. Let's look at another example like that. So over here, the 2 goes to what it is directly beside. So the whole -3 is the base. So the -3 is copied twice. -3 times a -3 gives us a product of 9. Over here, the 2 only goes to what is directly beside, so it only goes to the 3. So the 3 is the base. That is copied twice, and the negative you can just place out in front. And we get -9. Another example. The 2 goes to what it is directly beside, so it's directly beside the entire parentheses. So whatever is in parentheses gets copied twice. So this yields 16. The left example, the 2 only goes to the 4, so the 4 is the base that is copied twice, and the negative you place in front. 4 times 4 gives you 16, so the answer is -16. And the final example for even powers. The 2 goes to what it is directly beside the parentheses, so this entire piece inside the parentheses is the base. We copy that twice because the exponent is a 2, and we get a result of 25. In the left example, the 2 only goes to the 5, not to this negative symbol in front. So we copy the base of 5 twice, and we get -25. Now let's look at how odd powers affect those negative numbers. Well, the 3 goes to what it is directly beside. So it's directly beside the parentheses. So the entire -2 is being copied 3 times. -2 times a -2 is a +4. +4 times a -2 is a -8. Over here, the 3 goes to what is directly beside the 2. So the 2 is the base that is copied 3 times. The negative is just carried down. So we get -8. 2 times 2 is 4. 4 times 2 is 8. We get -8. Either way, you'll notice we got a -8. It didn't matter whether we had parentheses or not. Another odd power example. The 3 goes to what is directly beside. The entire -3 is the base. So we copy that 3 times. And then we multiply. -3 times -3 is 9. 9 times -3 is -27. In the left example, the 3 goes to only the 3. So the base of 3 is copied 3 times. The negative symbol you carry down, and we get 3 times 3 is 9. 9 times 3 is 27. Again, either way, we get negative 27. On the right side, once again, the 3 goes to the entire set of parentheses, so that entire piece is the base. Negative 4 times a negative 4 gives us 16, and 16 times a negative 4 is negative 64. In this left example, the 3 only goes to the 4, so the 4 is copied 3 times. The negative symbol is simply carried downwards. 4 times 4 gives us the 16, and then when we multiply that by 4, we get negative 64. Again, same answer. Let's look at this table. And I'm going to start on the even power side. The 2 goes to what it is directly beside, the whole set of parentheses. So we copy down negative 5 times a negative 5. And the answer is 25. In the next example, we copy down negative 5 4 times. Negative 5 times negative 5 is 25. Negative 5 times negative 5 is 25. And then when you take 25 and multiply it by 25, you get 625. And then finally, negative 5 to the 12th power, we multiply negative 5 by itself over and over again, and we write negative 5 12 times. What I want you to notice is that when you have the evens, the even power, you always have a pair. Let me count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. One more. Okay. And negative 5 to the 12th power gives us a very large number. I'm going to write that in another color so you can see it better. But that is this number right here. So it's 244,140,625. What I want you to notice here is that we have a pair, a pair, a pair, a pair, a pair, and another pair. When you have a pair of negatives and you multiply them, the result is a positive. So when you have an even power, you're always going to have a negative number times a negative number that cancels out and yields a positive number. Each piece is going to have its pair. Up here it's the same thing. A negative times a negative is a positive. A negative times a negative is a positive. So the final result is going to be positive. Up here we have a pair. A negative times a negative gives us a positive 25. All right, now let's look over here at the odd powers. And we have negative 5 times negative 5 times negative 5. Negative 5 times negative 5 gives us 25. 25 times a negative 5 is negative 125. All right, at negative 5 to the 5th, the 5 goes to what it's directly beside. So in all of these cases, the base, the whole thing that's in the parentheses of the base, we copy that down. So we get negative 5 times negative 5 is a positive 25. Negative 5 times a negative 5 is a positive 25. So then we take 25 times 25 and we multiply it by a negative 5 and we get negative 3,125. And then finally, negative 5 to the 13th power. The 13 goes to this entire parentheses. So we write out negative 5 13 times. 7 times, 8 times, 9 times, 10, 11, 12, and 13. And when you take negative 5 to the 13th power, you get negative 1,220,703,125. I think I said that wrong. Negative 1,220,703,125. So a very large number. And what I want you to notice here was that we'll have a pair, a pair. These will all make positive numbers. A pair, positive, a pair, positive, pair, positive, pair, and then we have the oddball. And if we have all of these together, are going to give us a positive number, but then you have to multiply it by a negative number, and a positive times a negative yields the negative. It's the same up here. We have a pair, we have a pair. Those are both positive. You multiply those together, but then you have to multiply it by the oddball. Positive times a negative is a negative. Up here, we have a pair, positive, and then we have to multiply it by our negative, so the result is a negative. So what I want you to get from this table is that when you have parentheses like this, and you have an even power, and we're thinking about negative numbers as the base, the result will always be positive. So even powers, the result is positive. Over here on the right side, if you have an odd power on a set of parentheses where a negative number is on the inside, or a positive for that matter, the result, if you have a negative on the inside of the parentheses and you have an odd power, you're going to always result with a negative symbol. So you're going to have a negative number every single time. So even power, positive result. Odd power, negative result. Let's look at some application. Over here, the 2 goes to what is directly beside. So the negative 3 is squared and the x is squared. Remember, power to a group, you're going to distribute. That was one of your rules that you learned. So the 2 goes to the negative 3 and the x. It goes to each piece. And here you know it goes to the entire negative 3 because the whole negative 3 is in the parentheses, and the 2 went to the entire set of parentheses. So this results in negative 3 times negative 3, which is 9, and then x squared. So 9x squared is our result. Over here, the comparison I wanted to draw is that a lot of students think, oh, there's a 2 here, so that also goes to the negative 3. That's not true. The 2 only goes to the x because that is what is directly beside. So this is a common student mistake to write this answer for this problem when the 2 really only went to the x, not to the negative 3. So this is as simple as this problem gets. All right, another application problem. Over here, the 5 goes to the whole set of parentheses. So the entire negative 3 gets a 5, and the x gets a 5. So this is negative 3 to the 5th. And remember, when you have an odd power, you're going to result in a negative number. So our result is negative 243, x to the 5th. And again, this 5 only goes to the x, so we can't do anything with that. You just leave that one alone. All right, now we're going to compare the odd power to the even power, and we're going to look at some more complex examples. And I'm going to leave this example to the next video because it looks like we're about at 15 minutes.